Welcome back. This is Balaban again. In the first part, I started a mini cluster of 2 instances on Google Compute Engine. Now I want to go to 100 nodes. So to do this, I cannot really use the GUI. So I actually wrote a few scripts which are going to start up all of the instances, are going to start UPerf on each of the instance, and so on and so forth. First of all, we want to change the type of the machine that we're starting. So if I look at the type of machines, the types of machines available, we have, as I mentioned this in part 1, we have this instance called N1 High CPU 4. So that's the instance that we're going to pick, and this is actually configured in my own script that I wrote, config sh. So we're going to use high CPU 4. And the number of instances we're going to be starting is 100. So we're going to start 100 one high CPU 4 instances. That's totals comes to 400 cores, and that's still within the quotas I have. Okay, let's get started. We're running the script. And this should start 100 instances. We can look at the console to see those instances getting started, and we're going to SSH into instance number 1. They're called box 1 to box 99, or box 100 actually. Do a refresh and we can see the boxes are getting started. This is actually pretty fast, and I'm trying to SSH into box number 1 already. Not yet. Let's give it a few seconds. While it's starting up, let's take a look at the script to start the 100 UPerf instances. There's a script called start all UPerfs. I'm actually going to go and start UPerf on box number 1, and then start 99 UPerfs on the remaining boxes, box number 2 through box number 100. So this box is still being started up. Let's try again. And now it's up. We're actually in this box. In box number 1. If I look at box number 1, you can see most boxes have been started. Box number 1, I can see the CPU is, we have 4 virtual CPUs and 3.6 gigabyte of memory. So far so good, so let's start UPerf on this box. That's the first instance that was started, and if we look at the cloud storage, we'll see that there is a directory under the JGroups bucket called UPerf that has 1 file in it, namely information about the first instance started. Now, if we start the additional 99 instances, I have a little sleep in here between the starting 2 instances. I think I should take this out, otherwise we'll see it'll take us 200 seconds. That's close to 3 minutes. Let's actually take this out and just run the all the UPerfs. Okay, start all UPerfs. What should happen now is that this view here should change from A to A, box 1, box 2, box 5, box 7, blah blah blah, and the number here should also change. In the end, this number should change to 100. Also, if we look in the cloud storage, and we do a refresh, we should see the individual instances placing their information into this directory. We see that this has already happened, and we see there's a view now of 5. So 5 nodes have already joined. What probably happens here is that because the boxes are started without a wait time between the individual starts, that we are creating a few partitions, and then those partitions merge together into one. Right now we see we have 59 members. You see the ellipsis here. At one point we're start. This can actually be configured. We by default show the 21st members of a view. Right now our view is 59. Now the view has changed. You can see this here to 86, and we're still waiting for a merge to happen to get up to 100. While this is going on, let's SSH into a box and use probe we used before on one of the instances, for example on A, to get information about the cluster. So by the way, you see now the cluster has formed. We have 100 nodes. Running probe, we get information about all of the members in the cluster. And if I, for example, look at the view, you can see that the view is the same everywhere. It's called A4. This means the view was created by A. A is the first member, so-called coordinator, and this is view number 5. The first view is 0, 1, 2, 3, 4. So it basically took 5 view changes to come up with 100 nodes. So let's now run our performance test. As soon as we press 1, then every one of those 100 members will invoke 20,000 synchronous requests on randomly chosen members in that cluster. And we get a tally of all the requests of all the members. The tally is here. If you look up, this is basically box number 65 was able to invoke 5,000 requests per second. Box number 50 invoked 5,735 requests per second for a total of 15,000 reads and 4,000 writes. So the total is 5,231 requests per second per node, and the throughput is 5.3 megabytes per second. Remember, we're sending 1,000 bytes around. We can do this a couple of times and the number will probably go up. Now the number is 11,000 requests per second. 12,000 requests. The throughput is increasing as well to 13 megabytes. So this is for a cluster of 100. Of course, if we change the payload, which is the number of bytes sent with a get, returned with a get or sent with a put, then this throughput will increase. We can set the message size by pressing number 8. So let's make it 4,000 bytes. If we run the test again, you will see there that our throughput increases to 43 megabytes per second. The number of requests slightly dropped from 13,000 to 10,000, but the throughput increased. And we can even go higher. Let's set it to 8 or to 10,000. 10,000. You can now see that the throughput increased to 99 megabytes per second. This is gigabit Ethernet, so this is actually close to the 125 megabytes max, close to 100 megabytes. Okay, what else did I want to show? I think this is it. I'm now going to start. I'm going to stop all of the instances and shut down my cluster, and In the next part, I hope to be able to show you how to run 500 or even 1,000 nodes. Thank you for listening and stay tuned.